So now that you know this is a problem which is going to be solved by dynamic programming, the first and foremost thing we want to do is set up our DP table. So again, if you remember from the previous class, I said the dimensions of your DP table are going to be equal to the number of input parameters you get. So here again you have two inputs, you will be given two sequences or two strings. So it only makes sense that your table is going to be two-dimensional. We represent the elements of the first sequence along the columns and those of the second sequence along the rows. We insert an initial dummy row and column of zeros to act as a base case. So I'll explain with the table. So let's say these are the two strings given to us, BDCABA and ABCBDAB. These are the two strings for which you have to compute the length of the longest common subsequence. So you will put the characters of one sequence along the columns and that of another sequence along the rows. Now, as you would have figured out from your coin change problem, there is some element of recursion in any DP table, in the way any DP table is filled. That is what we mean when we say the problem size n depends on problem size n minus 1 and so on. In some sense of the word, there is a recursion. So when there is recursion, you know very well there has to be a base case, which is why we have this row and column full of zeros. So if you ask me what it physically means, I would say it is LCS of any sequence with an empty sequence. So if one of your sequences is an empty sequence, it is just empty quotes, there is no string or no characters inside it, then obviously the length of the longest common subsequence is going to be 0. So if you want a physical interpretation for the 0 row and column, that is how you will take it. And the purpose of putting it in the table is when you recurse back, there will be some base case where you will have to stop, and this 0 acts as that base case. So you know that's what is given here. Now how do we define the value which is going to be filled into each cell? This is an important thing. Again, I'll draw analogies from the coin change problem which you're familiar with now. So if you take the coin change problem, CCP of I of j, I said, is the minimum number of coins required to make rupees j using all denominations up to I. So if you had 1, 2, 5, 10 and CCP of 5 of some exchange value, then it is the minimum number of coins required to make as many rupees using 1, 2 and 5. So similarly, whenever you have a DP table, DP of I of j should carry some meaning, some definition. So here in your longest common subsequence problem, how we defined it is LCS of I of j is the length of the longest common subsequence up to the first j characters of sequence 1 and the first I characters of sequence 2. Again, we'll look at the table. So let's say I take this particular grid. So it corresponds to character A from sequence 1 and character C from sequence 2. A over here and C over here. So when I fill in a value in this grid, we are going to look at how to fill in, of course. What is that value physically representing is the longest common subsequence between BDCA and ABC. So up to J characters in sequence 1 and up to I characters in sequence 2. So whatever is the longest common subsequence of those two fragments is going to be put here. So again, if you take this one, this cell here, it is the longest common subsequence between BD of sequence 1 and ABCBD of sequence 2, so on and so forth. So that is the meaning of your DP table, and this is the example. This is what the initial table would look like.